Hello, Big Reds. This is Unit 3 review video part 2, so if you haven't watched part 1, make sure you do that first. Okay, we're going to do some more problems that you need to know for the test. First one is, again, another isosceles triangle problem. Let's say if we had this was 2x plus 4, and this was 3x plus 3. Okay, I'm changing that, sorry. 2x plus 4 and 5x minus 5. Okay, so I know that these two would be equal to each other. So I'd take 2x plus 4 equals 5x minus 5. Subtract 2x from each side. And I get 4 is equal to 3x minus 5. Add 5 to each side, get 3x equals 9. Divide by 3, x equals 3. So there's one type of problem there for you. Okay, next one. I'm going to move this to the right a little bit. I have an isosceles triangle. Let's say I have angle or a side length. Let's say the side length is 12 here and 12 here. And I have an angle up here. Let's say this is 50 degrees. And I want to figure out what these two angles here are. Well, if this is an isosceles triangle, these two base angles are congruent. I take 180 minus 50 gives me 130 degrees left over. Now, since these two are congruent, I just divide this by 2. Each of these angles has to be 65 degrees. That's the next part. Okay. What else? Okay, let's say I have a triangle like this. And I have a bunch of algebra problems here. So let's say this is 3x minus 2 degrees. This is x plus 5 degrees. This is 2x minus 1 degrees. Well, I do know that all three of these have to add up to 180, right? So I can take x plus 5 plus 3x minus 2 plus 2x minus 1, and that's going to equal 180, right? So add these all together. X plus 3x plus 2x is going to be 6x. And I have 5 minus 2 minus 1 is going to be plus 2. So I have 6x plus 2 equals 180. All right, next thing I'm going to do is I'm going to subtract 2 from each side. I get 6x equals 178. And divide by 6, and I get what x equals. So x is going to equal, let's see what 178 divided by 6 is 29.7 approximately, if I round to the nearest tenth. Okay. All right, there's that type of problem right there. Next, let's say I have a right triangle. And move this up here. These don't have to be perfect, just look at the measurements. Let's say this is 52 degrees up here, and this is x, and I want to figure out what the missing angle is here. Well, I know there are 180 degrees in a triangle. Subtract the 90, and I have 90 degrees left over. Subtract the 52, and I figure out what this angle is. This is going to be 38 degrees. Next. Let's see, okay. Next, I have a triangle that's like this. And let's say this happens to be a right triangle. These both happen to be right triangles. And we'll label this A, B, C, and D. Let's say it tells us AD is congruent to DC. Well, that means this side's congruent to this side. And obviously they share a side in the middle. So this is going to be side angle side, SAS. Now a lot of you think, well, this is a right triangle, so it's got to be HL. That's not the case because you can see the right angles point to the hypotenuse, and there's nothing on the hypotenuse, so it can't be HL. It's got to be side, angle, side. Right. Next, let's say I have two more triangles. And let's say we have right angles here congruent. How would these be congruent? Well, you know the side in the middle is congruent here, so we have angle, angle, side. It wouldn't be angle, side, angle because you could see this side is not between these two angles, so it's going to be angle, angle, side. All right, next. Let's say we have two triangles that intersect, and let's say these two sides are congruent and these two sides are congruent. Are these triangles congruent? Well, absolutely, yes, they are. It's going to be SAS. Here's why. In the middle, you can see these two lines intersect to form vertical angles, and these vertical angles are always congruent. So that's how we get side, angle, side. All right. Another wonderful problem here. Now let's say you're given two triangles again. And these triangles happen to, let's say, this is A, B, this is D. Let's say it tells us that C is the midpoint of AB. What does that mean? Well, if it's the midpoint, I know it's halfway between, so I know this side's congruent and this side's congruent. Oh, and let's also assume that these are congruent, and then the side in the middle is congruent, so this would be congruent by side, side, side. Sorry, we want to assume that these are given to us. We know that these two sides are congruent because C is the midpoint of AB, and then DC is congruent to itself by the reflexive property. Okay, next. A couple toughies here, okay? So, let's say you have two triangles again, forming what in next unit we're going to talk about as a parallelogram. But we don't know if it's a parallelogram at this point. So, let's say this is angle 2 and this is angle 3, this is angle 1, angle 4. And they tell us that these sides are congruent and then these sides are also parallel. Okay? Well, if these are parallel lines, we know that angles 1 and 2 are congruent because alternate interior angles, and the side in the middle is congruent by the reflexive property. So we have side, angle, side, SAS. Okay. Now, a little slightly different problem. Looks similar, but say we do have a parallelogram for sure. And we have the same numbered angles, 1, 4, 3, and 2. And let's say that both of these sides are parallel. Now remember, I can write parallel with these triangles like this, or if I did it this way, I could say AB is parallel to CD, and I could say AD is parallel to BC. Now if that's the case, I have alternate interior angles congruent, actually two sets of alternate interior angles congruent, and reflexive property in the middle, so that they share the side, so it's going to be angle, side, angle, ASA. Well, let's see. What haven't I got to? Oh, a mid-segment problem. We can't forget about the mid-segment problems. So, pull this up. Say I have a triangle. We'll call this A, B, C, and this is D and E. Let's say D E is the mid-segment, which means D is the midpoint of the side, and E is the midpoint of the side. So they tell us that DE is equal to 2x plus 3. And they also tell us that BC is equal to 7x minus 10. And we want to figure out what x is. Well, since this is a mid-segment, DE, it's half of what BC is. So I have to multiply this by 2. When I multiply this by 2, I have to distribute the 2 to both of these. When I do that, it becomes 4x plus 6. Because I multiplied 2 by 2x to get 4x, 2 by 3 to get 6. So I take 4x plus 6 equals 7x minus 10. Solve this and subtract 4x from each side. And I'm left with 6 is equal to 3x minus 10. Add 10 each side. I'm running out of room here, sorry about that. I get 16 equals 3x divided by 3. And x equals 5.3 repeating. That's an example of a mid-segment problem. Let's see where we're at with time. All right, that's about all that you need to know for this Unit 3 test. If you have any other questions, please ask Mr. Fischel. I wish you the best of luck, and go Big Reds.